Okay, good morning, everyone, and welcome to our solid waste working group. This is the subgroup of combustion, gasification, pyrolization, landfill, gas recovery, and facility location. I'm Joe Gresco. I'm a state representative from Stratford. I am the chair of this subgroup. Thank you all for joining us this morning here on the Zoom meeting, and also if you're monitoring at home. We're tasked with potentially exploring options for the municipal solid waste that has been generated by the former and current Mira towns. And this is the opportunity to explore new technology, to explore what we do next as far as processing this municipal solid waste. And that's enough of me talking. And I do not see Senator Formica here, who would be the energy ranking member, but I do see Senator Minor. Senator Minor, if you'd like to make a comment before we get going here, please.
Just good morning, everyone. I look forward to whatever information we can get today. Thank you.
Thank you, Senator. And so we're going to go right to item number 3 on the agenda, which is the presentation by Connecticut Gasification. As I've tried to reiterate to everyone, we're going to try to keep the meeting to about an hour, so that including questions by members, only out of respect for everyone's time. And we will have future meetings as we go through the next few months, as we invite more people and more entities to give us their opinions and their options. But that's item number 4. That being said, I'm going to turn it over to Keith and John and I don't know who else. I think Barry, you said from Connecticut Gasification for their presentation. Thank you.
Thank you, Representative Gresco. My name is Keith Holbert. I am the CEO of EnviroPower Renewable. We have our partners on the phone, John Barone and Rob Gasolfi, and our Chief Technology Officer is also with us, Barry Wilson. I want to apologize in advance. I know the meeting's moved around a bit, and I have to drop at 10:45, which is really good because that'll make for a very abbreviated presentation for you to absorb. But I'm going to share the screen right now so you can see some information as we talk through this. Just a moment. And at this time, I believe, do you see an EnviroPower Renewable PowerPoint presentation in front of you?
Yes.
Yes.
Good, good. I just wanted to confirm.
Nope, got it.
So let me just walk through this a bit. EnviroPower Renewable does work both in the US, Canada, as well as currently in the UK and selected other countries. Our focus is to convert waste streams into renewable power and waste streams into renewable fuels. And 2 different waste streams for those purposes, and we'll touch on that in a moment. Our key focus is primarily on the elimination of waste in a manner that's cleaner than most current forms of waste conversion. And that's been a challenge within the industry for quite a bit of time. And also at the same time, create grid stability, because plants that are not reliable create a lot of downstream issues when it comes to consumers of the electricity. The team of EPR, we have deployed well over 4 gigawatts of thermal energy plants. To give you a comparison, that's about the size of Connecticut, Massachusetts, and New Hampshire combined. We come from running utilities, running transmission grids, launching thermal energy plants and waste energy plants throughout the UK as well as the US. When we look at a project and our technology that we're going to touch on in a moment, we focus on low emissions gasification. And that's because emission requirements are a continual focus and will be a more important focus as we go forward for any thermal production facility in order to lower the greenhouse gas effects that we're all experiencing. We can convert green municipal solid waste with moisture contents up to 55%. That should be well below what Connecticut experiences. We can take in MSW, construction demolition debris, or any traditional waste stream that would traditionally be formed or has been destined for landfills. There's a lot of applications where markets want to destine food waste to go into anaerobic digestion. That's fine. We're not in competition with that. That's a very effective use. If that makes sense and Connecticut has a plan for that, that's great. If not, we can even take food waste into our facility. From a technology perspective, we use rotary kiln gasification. This is very different, and we'll show you how that's different than traditional incineration, which you may have heard about or be familiar with. We also use low NOx burners to reduce the emissions before it goes through the process. We operate at relatively low temperatures within the rotary kilns, below 1800 degrees Fahrenheit. And we make sure the fuel gas is retained for more than 2 second residence time, which helps in the elimination of particulates and volatile matter. From an operational standpoint, we have a big focus on operations because, like I said earlier, a lot of us have operated thermal plants our entire career, and we're going back to basics. This is a very basic power plant that's been designed here. It's proven, it's been in the markets, it's been used for a lot more tougher material to process than municipal solid waste. From an environmental standpoint, I'll show and touch on how we can actually lower greenhouse gases from the processing of your waste stream. And there's a lot of economic benefits. These plants are relatively economically attractive to build, and they're all designed for a 30-year life. And that's just because manufacturers of equipment don't go beyond a 30-year life engineering design. The last 3 power plants I operated that were designed for a 30-year life, I retired them in their 60th year. So that kind of gives you an idea. I thought it'd be good for us to first touch on what has been traditionally the form of converting waste streams to energy, which has been in the form of incineration. Incineration consumes a lot of excess air compared to our system. And because there's so much air introduced in an open burn environment, that means the emissions have to be dealt with as it comes out of the system. And because of the volume of air, it generates more particulate material, NOx, and volatile organic matters. Those are the key issues that affect either the reliability of the plant or the emissions coming from the plant, which is the focal point of what the EPA and DEEP will be focused on. Traditionally, and for most of the incineration plants we've seen, the ash byproduct, about 90% of the mass is converted to electricity, about 10% results in ash. Most of that ash is unusable, and it sometimes is categorized as a hazardous waste and needs to be landfilled. Compared to our gasification approach, we reduce the air volume so we reduce particulates, VOCs. We put it through a low NOx burner, so we reduce NOx in the process. And we still convert over 90% of the mass into electricity. However, we also have a patent on a sintering kiln. So we take that ash, we put it through the sintering kiln, and we create a pebble out of it. That pebble will be tested and has been tested. It'll be carbonless, it'll be non-putrescible, and it can be used for substitute concrete material. And in today's market, that's pretty important. Concrete has gone up in price significantly. And this is a lighter, stronger material, and it's used as an aggregate in that process. It could also be used for road fill, base material for construction, or alike, but it is not landfill and it is not hazardous at the end of the day. To give you a point of reference, here are some pictures of rotary kiln plants. We are partnered with Metso. We have several patents on this process. We have a team, and as I mentioned earlier, Barry Wilson, our Chief Technology Officer, leads our technical team. We have a team of scientists and engineers who've worked in this industry and with these plants. Our patents result in a more efficient processing of the fuel to get more power out of it in a cleaner manner. So we introduce a recirculation of flue gases, which makes it a lot cleaner and the plant more reliable and predictable performance over the 30-year life. We have the sintering kiln, and then we have the low NOx burner. These are what kilns look like. Metso produces 70% of the worldwide market, mostly calcining kilns. They have about 30 kilns that are waste energy plants they've deployed. And we've got about 50 rotary kilns that are deployed as calciners throughout the US and overseas, which is virtually the same design of what we're talking about here. This is a picture of actually a rotary kiln that's been in operation since 2014 that takes run-of-the-dump waste. It's not sorted other than large items. They just basically take the waste stream, put it right in it. It's been operating very effectively. I call it a generation 1 gasifier, but it's representative of the durability of these units. They've been eliminating waste streams, like I said, since 2014, compliant with EPA purposes. It's been reliable. It's just not nearly as efficient as what we would design. But you can see some of the scrap metals that come out of it and the ferrous metals that come out of it that are later resold. But it processes all the traditional waste streams that are brought to it. This is what the rotary kiln looks like. We enter the feedstock on one side, on one end from a feed auger or a ram feeder. We bring in the air to the other end, and we have 4 stages. We dry the material, get the moisture content right, then we gasify it, then we do the carbon burnout, and then there's the ash cooling process. In between, there's a onboard fan, and that's where we recirculate the flue gases. And this is really the key differentiator here, is this reduces the volatile material and particulate matter, and that creates more reliability and a cleaner burn system. This is a representative example of the temperatures that we use that would be more interesting to your environmental personnel that would want to look at this, but it's a relatively low temperature process. This is basically schematic layout. Everything in the lower right-hand corner in the green is the power transformation to the grid. We introduce the MSW to either, depending on the volume, the size, through a ram feeder or auger feeder. It may require a dryer if it's very wet. In Connecticut, I wouldn't expect that. introduce it to a rotary kiln, put it through the low NOx burners, through the boiler and the air cleanup system. We spend a lot on air cleanup in our systems. And let me just give you an example. If you look at this color coded, I don't know if the colors come through well or not, but these, and you'll have to forgive me, I'm partially colorblind too. I think these are kilns off to the left. Those are the kilns. This is a representative example of a system that would handle fairly good sized large volumes. We size it appropriate for the volumes come in. Everything you see in red is focused purely on the emissions and the cleanup of the gases that go through this system. And we spend a lot on that. And the purpose is, and I'll show you shortly how clean this is, but our plants, megawatt for megawatt, are cleaner than the cleanest natural gas fired plants there are in the market. Let me move on here. Oh, the other point I wanted to make is we designed this to utility grade standards. What that means is we put a lot of redundancy in the system. Our team is very skilled at maintaining plants while they're operating. And the way to do that is you put redundancy. So if we need 3 kilns, we'll probably put 4 kilns in so that we can do live maintenance while the rest of the plant is operating. So we can achieve uptimes that a utility would expect. And we designed for roughly 50 out of 52 weeks on a normal annualized basis that we'd be operational 24 hours a day. Every 7 years, when you have major shutdowns, you're down for about a month to a month and a half, and we coordinate that with the grid to make sure that we're coming down at the right times with the load cycles of the clients. To give an example of how clean this system is, the Environmental Protection Agency has standards for all greenhouse gases. Most of these constituents are listed both in the chart as well as in this grid. What I really want to draw your attention to is this is based on a 1,000 ton a day plant that we've done some analysis on that we're, and these are the environmental EPA standards that have to be achieved. But this is the performance standards in the last column of how our plant operates against that. And if you can see that, we're roughly running around 15% of the allowables. So for a 1,000 ton a day plant, we're considered a minor source in the EPA classifications, which is exceedingly surprising to most people in the waste energy industry because we are so clean, and that is cleaner, like I said earlier, than the cleanest natural gas fired plants we have. When you evaluate taking waste, putting it in a landfill, we're actually a negative greenhouse gas producer because a lot of the landfill material turns to methane. That's anywhere from 35 to 38 times more potent than CO2. We process all that obviously through our machinery, so there is no landfill. So when we do the emissions measurements, we're actually a negative greenhouse gas producer, which helps us when it comes to renewable credits and the like. If you look at the particulate material, you're always having to measure on the property boundaries, and we've had to do this also. That's what this chart in blue on the right is. At the property boundaries of that particular site, our particulate material would achieve a much lower standard than standing on the side of the road that has a diesel truck running down it periodically. So we are exceedingly clean. give you an example, California, which is a challenged market when it comes to thermal energy production, has certified us as a minor renewable source by their standards. And while they've qualified us, it's a different issue to try to build a thermal plant in that state. So we were looking and we have a project on hold in Nevada where we will transport our electricity over the border to help them out. And they've certified this as a renewable source by their standards, which is pretty tough. We've also gone through a review with the state of New Jersey, who has moved their emissions requirements to about 25% of the federal EPA requirements. And our plants easily achieve those standards as well. And we're in discussions with them on a plant currently. Like I said earlier, we also can take certain fuel sources and convert that to fuel, usable fuel, renewable fuels. And what we can do is through hydrothermal liquefaction, which is a process which basically we take plastic and we return it to its former form of petroleum. And we do that through a water process, through a duration of temperature and pressure. And we can get various cuts of fuel, which would be classified as renewable and low sulfur. And that would be just if there's sufficient volume of plastics. We have a project in Canada and in the UK that's specifically focused on this. And then any residual material will go through the waste energy plant. But there's a keen focus to get, and where there's shortages, especially in the US, is on refining capacity, but is to get renewable diesel, renewable marine fuel, and renewable jet fuels. And we can get those cuts out of a sufficient volume of plastic also. But that's really a different conversation. I think the key focus here is to focus on the waste streams that Mira has been dealing with. So rather than summarize, I kind of touched on all the key points. The key information we look at when we look at a project is what volume of waste is available. That's obviously the key. We've got to design around the volume. We can take whatever volume there is. We just build our plants in series. We don't redesign anything significant. We just build plants in series next to each other. It's proven, it's capable, and that's the best way to do it. In the state of Connecticut, we've looked at your waste streams. We've been talking to the state, I think about 4 years now. So to various members. So I think in total, you've got volumes that would necessitate plants probably in the Southwest, where you have the current Covanta plant, somewhere's in the midstream and somewhere's on the East Coast or lower East Coast, or lower eastern corner of the state. It makes sense to keep distributive energy plants, keep them of the size that you're not changing traffic patterns for waste streams, get it as close to the waste streams as possible and get sufficient volumes to get the plant up and running. The other key is we need to convert this to electricity. So we need access to the transmission grid and somebody who's going to buy the power, whether it be a commercial customer, water plant, or the utility itself and put it on the grid. We can do it either way. We need long-term contracts for our financing partners. We have financing partners lined up to fund these plants, and we do it on a JV agreement with them. The key for us is site availability and permitting. We need to have certainty over permitting, and that's going to be a key for any market we look at. We have actually more markets coming to us than you can imagine. And the ones that we tend to focus our engineering attention on are those we have certainty of permit. Permits can take, in the US, is actually the hardest market we deal with in permitting. Most, Canada, UK, England, Scotland, Ireland, it's all very predictable. It's pretty straightforward, and it's usually done in advance. You have to design your plant and demonstrate the compliance, but you're talking weeks, not months or years in the permitting process. So that part is really the biggest risk when we deal with certain states or jurisdictions in the US. And that's an area we need to talk about if this is something that the state wants to consider. We do have projects. We do what's called BOT, build, own, transfer, or build, operate, transfer. We can fund, we can build it, we can train people, we can transfer it. We have customers in the industrial space in the US that we will transfer the plant over to their operations for their waste streams specifically. These are large industrial plants. And they will operate it along with their industrial application. We also have electric utilities we're dealing with overseas. We're going to do the same thing we're going into contract with one in the next month that we will be doing this for them, and they'll operate this plant after we build it and train them how to operate it. That's the end of the presentation. We can make this presentation available to you. We've got the credentials of our executive team on there. And we'd be happy to answer any questions. If 1045 comes and I'm missing, Mr. Barry Wilson, our Chief Technology Officer, can answer any issues.
Thank you, Keith. You answered one of my first questions, which was, can you please get this presentation to Gaia, our clerk, so she can funnel it down to all of us going forward. And in the interest of time and for questions, I have questions, but I'm not trying to monopolize here. So we're going to go to everyone else who has their hands raised first. And Senator Minor, you were first, followed by James Albus from Connecticut Deep.
Thank you, Mr. Chairman. Thank you for that presentation also. So I have two questions. The first has to do with the timeline that you spoke about with regard to permitting. It's been a focus of discussion, I think, in the state of Connecticut for decades. Is it your opinion whether it's getting better here, or is it as bad as it's always been? And secondarily, you spoke about a certain period of downtime, planned downtime, and I'd be curious to know in other applications, how do the states or countries deal with the waste stream during that period of 30, 60, 90 days? Those are my questions.
Good questions. Permitting, I can't say if it's better or worse. I don't know, to tell you the truth. And I think Deep would be the best to give us an assessment. The key would be when there's a need like Connecticut has, and the need is focused on the waste, which it should be, there's a big part of this equation that's not answered. And it's kind of like, well, you guys go find a piece of property, go buy the property, put your money at risk, and then permit it. And we'll tell you if you get the permits. That's not going to compel a lot of people to jump into this. I think this has to be a partnership approach. Deep's got the know-how. They know the state. The cities know their markets. I think we need to narrow down some sites that Deep can in particular say, yeah, we can get things permitted here. Obviously, we've got to do our work and do the design for them to do their review, but that's the key. It needs to be predictable. We are talking to Jersey, and I'm quite honest with them. They, along with a few other states, have a reputation of businesses leaving because of permitting. You get so far in the process and your budgets can only carry you so far on something that doesn't turn real. So then you turn to something else that is real. And that's the key focus. We got to get that predictability. The other point is on downtime. Downtime is usually scheduled with grid operators. So it's during the off-peak periods, and we schedule the maintenance when the power is least needed. So we can be flexible on that. All power plants do this on an annualized basis, and we usually set schedules with the generators to the grid every year. It's usually a multi-year planning cycle. So that's typical in the industry. We have no problems there. As far as feedstock, we always like to carry feedstock on reserve in case there's anything like a strike, a storm impact, a bridge, a road, anything like that. So we like to keep supply on site that we can operate for a few weeks straight. During the period of downtime, what we will do is we will diminish our reserve supply during that period and allow the continual stream to come in so it's normalized. And we plan for that every year. So we do that with the waste operators or the delivery folks who would be bringing the waste. And we would just schedule it so we have adequate supply reserve on site. And then as we approach a 2-week outage, then we start pulling from that reserve and produce more on the grid during that period of time, because we have overproduction capabilities with these plants. We can produce design.
Thank you.
Thank you, Senator. Next, James Albus from Deep, followed by Jason Manifold.
Thank you, Representative Gresco. Keith, thank you so much for your presentation. I thought it was very informative. My name is James Albus. I'm the director of the Office of Policy and Planning at Deep Spear Materials Management and Compliance Assurance. So I'm not in our permitting division. I can't speak as intelligently to that side of the agency as you might like here, but I do have a suggestion, which is, when you all are comfortable, we do have a pre-application process through our Office of Client Concierge that has been, from my understanding, very helpful for the regulated community. It brings forward all the various aspects of the agency that could be involved potentially in permitting, including air, solid waste, stormwater, if that's necessary, to give applicants or prospective applicants kind of an idea of what the requirements are, an idea of what the timelines would be. So, that could certainly be helpful for you as you think about, the potential for moving forward in Connecticut. I will say siting is still, a difficult issue. And we've been having a number of conversations with the regional councils of government and a great deal of municipalities across the state to try to find adequate siting for various types of solid waste infrastructure. And, it's, as you might expect, municipalities are often wary about agreeing to be a host community when they don't know what a proposal is. So I think, we're happy to try to facilitate some of those conversations with potential sites. But again, it's been hard for us to identify even where those might be due to, a lot of the hypotheticals that might be involved. But we do want to be helpful there. I do have a couple questions. First of all, I was just curious. I saw in your slide deck, you mentioned green municipal solid waste. What do you mean by green MSW?
Yeah, green MSW is unprocessed MSW. In other words, it's just brought in straight away. So we do the sorting of pulling out the metals at the site and sell those off that could be reused. Virtually nothing else is really reused these days. Metals is, and that's about it. We have very aggressive recycling campaigns, but the question is what's really recycled at the end of the day. Food waste has been processed for agricultural purposes very effectively, and that may or may not apply. And if it's great, but that would have to come post-sorted. So when I say green waste, we can take in waste streams straight from the processing. If it's already pre-sorted through a MRF, we take C&D and the process waste afterwards.
Got it. Thank you for that.
Mm-hmm.
And just curious, what is the typical capacity of one of your types of facilities for processing MSW?
The smallest one we're looking at right now is for a coastal community offshore, and I think that's going to be about 8 megawatts processing about 350 tons a day. We can go up to a couple thousand tons a day and make it like a baseload power plant, but then you get into issues of grid. Can the grid handle that much load in a new location, or is it going into a pre-existing location that used to generate that? So sites that tend to have larger plants are usually close to mothball power plants, close to landfills, or former plants that used to exist, because utilities rarely take down their equipment after the fact. They'll go for the substation equipment as they need it for maintenance, but the wire size and the transmission line remain. So those are ideal site locations for us.
Hey, Keith, why don't you just explain how it's the EPR system is kind of modular, so it could go from smaller size plants and easily expanded?
Yeah, so sometimes we're dealing with a plant location right now that they're anticipating that we're going to be bringing in, give or take, about 700 tons a day, but they think there's going to be more coming forward. So we just have adequate land available and we plan for that. We don't put the equipment in. We just plan for how it would be located at the same site, through the weigh stations, through the sorting facility, if we put a sorting facility there, and make sure there's an adequate substation connection at the end of the day.
Thank you. Thank you, Keith. Thank you, James. We're just before we move on to Jason, what footprint size are we talking about here, acreage wise, that you would need?
Yeah, it depends on the volume coming in. So our plant that we're working on in the UK right now is about on 11 acres, and that's going to produce 27 megawatts and bring in 800 tons of waste a day.
Thank you. Next is Jason Manafort, followed by Dave Stewart. Hi, Dave.
Thank you. Keith, you said you mentioned you were talking with the state for 4 years now. Did you participate in the procurement the DEP did when they were looking to redevelop the Mira plant? When you had a site, you had a permit you could have modified, you've got a connection to transmission, all the things you need?
About 4 years ago, DEEP was doing a review of different technologies that would be considered and acceptable within the state. And that's when we presented our technologies at that time. But no, we were not aware of the repowering or proposal for the Mira plant. But
so they didn't accept your technology is acceptable for the procurement they put out, or
yes, it is.
You didn't meet the threshold of what they were looking for, so they didn't want to talk to you, is what you're saying?
We did meet the threshold, but we weren't aware of any procurement.
Wow. Okay. I mean, it was at least a 3 year long procurement. That, I mean, somebody else could correct me, but it went on forever. Before the wheels.
We were never notified. And quite honestly, these procurements are going on in every market in the US. We don't monitor every market. We go after those that are right in front of us that really have immediate plans.
Okay, because I thought you'd mentioned you were speaking with the state for 4 years. I didn't know who you were talking to.
We had on qualifying our technology back when they were doing a strategic review on various technologies to process waste.
It just seems like you had everything you were looking for in the Mira plant before the wheels came off, and now, when they were considering rebuilding that plant, if you will, looking for different technology than the current or former RDF plant that was there, that would have been your It would have been the opportunity for you to have all the components for you to.
I'm pretty familiar with incineration plants. I've operated them. I've actually converted an incineration plant to coal to make it cleaner and more reliable. But there's not a lot you can do with an incineration plant with our technology. It's basically a rebuild.
No, I agree with you. It would have been a rebuild, but you had a building, you had a site, you had a permit that you could have modified for your technology, and you had the connection to the grid that you need. You had all the pieces you need.
That's the key
right there, and they were looking for you.
Yep, that's the key. And I apologize in advance, but I'm going to have to hand off to our CTO. I apologize, but this was a preset meeting overseas I have to attend.
Okay.
Thank you, Keith. Appreciate it. Next, we're going to go to Dave Stuber, followed by Frank Antonacci. And Barry, you're with us?
Yeah, please tell me if I am. I was having some problem. Okay.
You're fine. Yeah.
All right, go ahead, Dave.
Thanks, Representative. Appreciate that. Folks, I'm Dave Stuber. I'm the Chief of Staff for the City of Hartford. I'm also sit on the Board of Directors of the Material Innovations and Recycling Authority. Nice to be with you all. Two questions for you, Barry. The first one is a little bit more simpler, so I'll put it first. In the course of your process, since you're essentially looking to extract, volatile gases out of the waste stream and then harness that for energy, is there any leakage or escapage of methane or other, notable potent greenhouse gases into the outside air in the course of that process? And how do you think about that and trying to control any of that type of leakage in the course of the process? My second question, our panel overall is going to be considering a wide variety of technologies. And so I wonder if you might care to comment for a bit and compare and contrast your gasification technology to anaerobic digestion as a potential alternative, both in terms of overall, feedstock that would be required, relative efficiency and energy extraction or other benefits. And then I'm also curious, if it might make sense for us to think about, if you could offer thoughts on whether or not, pairing anaerobic digestion with gasification would make sense in any combination, or is the portion of the waste stream that would be used for anaerobic digestion really something that you would need and would rely on those organics in order to make your process efficient?
Thank you. To go to the first question, first of all, can you hear me? Because I was having trouble. Okay. To go to the first question, this plant, and I don't have control, I don't have screen control, but if you notice the schematic of this plant, you saw a great big ID fan just before the stack. That induction fan holds the whole process at negative pressure. So if I take a nail and, punch a hole in the side of one of my, let's say one of my gas lines on the gas path, then all I hear is a sucking sound. Okay. Now inside it'll look like a little blowtorch, and I don't want to run like that, but nothing gets out. Okay, that's number one. Then with regard to anaerobic digestion versus, okay, first of all, anaerobic digestion normally works with material that is at least 50% moisture or higher. Okay, can we agree on that? Okay, and anaerobic digestion is it's a perfectly good process. When you compare it to gross weight or bulk material, your energy extraction is, your thermodynamic efficiency is 15% on its best day. Our total overall end-to-end thermodynamic efficiency is between 23 and 28%, depending on what the scale of the plant is. So that's number one. Anaerobic digestion is probably best for food waste, just straight food waste, is what they do in Las Vegas. They have a pig farm, and they just haul the stuff out and feed it to the pigs, and everybody's happy. You just have to make sure that there's no plastic in it. But anaerobic digestion is perfectly reasonable for that type of material. And the answer to your last question is pairing. Absolutely, be more than happy to do that. But Robert can tell you more about that. There's going to have to be some type of separation, either And the best would be source separation, where you have the dry stuff on one and the other kind of on another. So, but the answer to pairing is absolutely.
Yeah, and you know, the anaerobic digestion cannot solve everything that's going into the existing mirror plant. The EPR system will. So you'd have to figure out what to do with the rest of the waste that's the anaerobic digester cannot take. Also, the EPR plant has a MEM system, a SEM system, a constant efficient monitoring system on the stack, so that the DEP or anybody could dial into it and see what the emissions are. And it's also monitoring to make sure it's below the EPA or the Connecticut regulations on a regular basis. And then just to note, we are working on several projects in New Jersey, and we already did a waste characterization study with the New Jersey DEP, and they gave us the nod for, you know, we beat all of their regulations. They are actually 75% below that of the EPA. So very stringent, and at 1,000 ton per day plant with the Atlantic County waste characterization, we were able to beat those numbers. And they actually said that, you know, EPR actually went above and beyond to clean the airstreams for that plant.
One quick follow-up question, if I may, Mr. Chair. Just as a point of clarification, so if in theory we were to do some separation of the waste stream and to pull out organics and funnel it into an anaerobic digestion process, would that impact the efficiency of a gasification plant if the remainder of the waste stream were put into it? I mean, because on the one hand, I could see, okay, well, you're pulling out organics, you're pulling out water, so you might require less fuel to, you know, get your gasification system up to temp. On the other hand, you're pulling out potentially some of the you know, combustible material that you might be able to harness out of the process. So I just wonder how to think about that in terms of potential pairing of the technologies as a part of a broader system.
That was one of my questions.
It's going to be more economically efficient and thermodynamically efficient to do the separation. Because if there's separation, then you don't have to have as much capex for the gasification plant, and the capex for gasification per ton is higher than anaerobic digestion by a lot. Okay, so what you do is first of all, you get a good waste characterization, and then you just run optimization algorithms, which we have. By the way, just so everybody understands, we do computational flow dynamics with ourselves and with the manufacturers, and our whole system is computerized. So we have a lookup table. We can take your input parameters, put them into the lookup table, and do you know, best solution runs in a day. Okay, so we don't. It's not hard to do, but it's garbage in, garbage out, not to make too much of a pun, but you really have to know your waste characterization. And again, if we're going to do that, then source separation is really the best. Have the restaurants and the really, you know, the food providers and so forth do that separation there. And so Robert doesn't have to do it at his plant.
Very helpful. Thank you.
Thank you, Dave. Thank you, Barry. Next, we have Frank Antonacci, followed by Brian Paganini.
Thank you, Representative Gresco. And thanks to the Enviro Power Group for coming today. It's an interesting presentation. Just as a form of comment, to dovetail off of what Jason Manafort said, I'm a bit skeptical of understanding why a group like yours hasn't stepped forward during the public RFP process for MIRA. Anyone who was following the solid waste management throughout the country was aware of what was going on with the facility in Hartford. So,
okay,
just begs the question for me first.
Yeah, Keith. I'm the technical guy. Keith is the manager. Here's what I know about the situation. I know that we spent time and money and went up there in 2018 and sat down and made a presentation. They said, fine, we like it. We'll get back with you. I believe Keith went up there in 2019 or 20, and it was decided that our technology really did meet their requirements. And again, we'll get back with you. We never heard anything. And again, we're a small company. we have more business than we can handle right now in terms of people asking, but we have to be very careful about who we go forward with. And as Keith said, if it doesn't look like because you might be surprised at how many people come and look at this and get started, and then for some reason can't get it done. Okay. And so unless we have been contacted and said, we're ready to go with you, we're ready to enter in, we wouldn't have done anything. And I know that we were not actively contacted about that. Keith is from Connecticut. He has a lot better connections up there than I do. I don't know how we missed, but it wasn't for lack of technology or effort on our part. So
am I hearing, in other words, your company would not be interested in any kind of competitive process?
No, that's not the case. It's just EPR did several presentations and contacted Connecticut, worked with them on finding a solution, and they were waiting to hear back. They said they were told that they would get back to them, and they never got back. But within the past year, we've had several presentations to the DEP. We filled out that form that James referred to, and we had a whole panel of DEP members from every different division. And basically, they said, well, we can't go any further until you find a site. And basically said, okay, well, when the state finds a site, we'll go do it. We're not going to go buy a piece of property and then have somebody tell us that it's not going to fit. We have to work as a team to find a location, and our technology could definitely be used. So we already went through the process. We filled out that application and the forms for the DEP. So we've been actively pursuing this over the past year as well.
In response to the comment, would we go into a competitive bid? Absolutely. We just did it in New Jersey, and Robert, you can tell him what happened in New Jersey when we went into competitive bid. We were the only. I'll tell him we were the only one that qualified. So we were the only one. We were the only bidder that met the qualifications that they had set forth in their request for qualifications. Not an RFP, an RFQ. We were the only compliant bidder.
Well, thank you. I do have a couple other questions. One would be, does EnviroPower currently operate any facilities?
Currently, we do not.
Has EnviroPower ever run a facility?
The EnviroPower, as Keith showed during the presentation, EnviroPower is comprised of a number of individuals who come from different walks of life. And among us, if you take our stacked up resumes, and I don't know, I wasn't in audio at the beginning. I don't know if Keith mentioned this or not, but EnviroPower executives in total have operated more than 4 gigawatts, installed, operated, and maintained more than 4 gigawatts of generating capacity, and built plants in the UK and power plants in the US, but not gasification plants in the US.
Yeah, it's also to note that the heart of the EPR system is the rotary kiln, and the rotary kiln is a Mezzo component, and Mezzo has rotary kilns operating around the world. Many of them in the US actually function with MSW, various industrial wastes that are a lot more difficult than municipal solid waste and C&D. But the EPR design and patents around the Mezzo system to handle MSW and C&D have been approved by Mezzo, and Mezzo is actually willing to warranty the whole plant for the life of it.
So a couple other questions. So because you mentioned the resumes, and it's unfortunate that Keith, the CEO, was not able to continue on with us, but I did look on the website, and amongst a litany of other accomplishments, Keith lists that he's the general manager of the Limerick plant. Can you explain what the Limerick plant does, and has that been successful?
I'm not sure where you saw the Limerick plant was a plant in Ireland. And we designed it. It was actually in a little town called Gordadroma in County Limerick. We designed it. We spent a couple of years over there working on it. And we were American. There was a company that came in that was Irish that had a competing plant that was an incinerator in Cork County. And Cork County slipped in ahead of us and got the waste. And if that's still on his resume, then he just hasn't updated his resume. But no, the Gordadroma plant was although it was completely designed and it passed the first stage of permitting in Ireland, it lost its waste commitment to an incinerator in Cork County.
Right, we're gonna go back to Brian next, and then Jeff, but only because we're after 11, and there's 3 more people that want to have some questions answered by these guys, if you don't mind. So next,
I would encourage everybody to do some Google searches on the company. Thank you.
Brian, you still there?
I'm still here, Representative.
Okay,
Glasgow, yes.
you were next, and then we were going to go to Jeff Martirano.
Thank you, sir. Thank you for the opportunity. Thank you to the Enviro team for giving a very compelling presentation this morning. Just a couple questions, and obviously want to keep it technical for Barry's sake. Relative to process validation, we ourselves are quantum operator anaerobic digester, and we're very familiar with operating here in the state of Connecticut. And we know that we couldn't have done this project or gotten this project off the ground without a litany of project partners, including our engineering teams. So just a question for Barry: is there any third-party validation of the EnviroPower process? And if there is, are you guys comfortable sharing that validation? And if you'd be so inclined, is there an alignment with a domestically located engineering firm? Because the scope and scale of the project I think we're talking about is fairly substantial. So just curious to see if you guys have gotten that alignment and if there's any third-party validation available for this group to review.
There is. It's ESI of Tennessee is the engineering and EPC company. And I'd be glad to give you contacts there. ESI of Tennessee has done a number of power plants in the Southeast, and they're going to be the EPC for our plant that Keith mentioned in Costa Rica. So the answer is yes. We've also been validated by several permitting entities who have scrubbed us with owner's engineers. And then, of course, there's Metso, who has run along with us the computational fluid dynamics and said, yay, verily, this thing works very well. And okay, go ahead.
So Barry, if you could get that information to Gaia or Rob or John, just so that it can be funneled to everyone on this meeting, those commitments that you just, and those verifications that you just mentioned, just so we can funnel that down.
I will. That'll go through Rob.
Great. Sorry, Brian, go ahead.
Yeah, and final question for Barry. Just curious if there's any current operating data that you could share with us based on Metso's experience in operating the EPR process with MSW. I think getting some real world data would help this group to consider some of the opportunities and some of the thoughts around this technology.
Metso has not operated our system with MSW, but they've operated systems that are very close to ours with MSW and a number of other rotary kiln feedstocks. Again, that's a $2 billion a year company, and they're willing to put they're willing to wrap it, with their books. So the guarantees are there.
Thanks, Representative Gresco and Barry. No further questions from me. Thanks.
Thank you, Brian. Next, we're going to go to Jeff Martirano, followed by and concluding with Don Stein. Jeff?
Yep. Yeah, I'll try to keep my questions technical in nature as well. So I'm wondering, do you have any example mass or energy balances that you could provide from either an existing facility or a proposed facility of a certain nominal throughput?
We do, and we'll provide those. Again, we run these on proven computer simulations. And so what you'll get is 12 pages that follows every molecule from the feedstock up the stack. So, or out as the bottom mash. So answer is yes.
Okay.
Where should those be sent? Rob, can I just send those to you as well as a conduit?
Yeah, just send me everything and I'll phone it through.
Thank you.
My next question is related to the moisture content of MSW and it being, potentially very variable. Do you need a dryer if the waste is less than 55% moisture content? Is that the threshold that you?
Again, it depends. We like to have, ideal waste would be 25 to 30%. We know that at 40%, we don't need a dryer. It depends on what the other composition is. If there's a lot of plastic in it to increase the average calorific value, then we wouldn't need a dryer. If it's mainly just paper pulp, something and food waste, then we would use a dryer. So again, it depends on the waste characterization. We like to have our stuff go in the front end at an HHV of 6,000, at least 6,000 BTU per pound. So if you're familiar with that type of,
Yep.
The higher heating value, 6,000 BTU per pound.
Yep. I do a lot of work in the waste energy field.
Okay.
So BTU per pound is what it's all about. So I guess there's a follow-up question there then. Can you describe the process on the front end that you would go about to try to homogenize the moisture content of the incoming waste? So, are you going to have a pit and a crane and a grapple like a traditional mass burn facility where you can fluff and mix up the waste before it gets loaded into the hopper, or how would that process work?
The first thing that, again, depending on the waste, normally we would, if it comes in with bags and so forth, we would shred it in a pre-shredder. And then if we dry it, that would get mixed there. But in terms of having to really mix it up so it's steady minute to minute, hour to hour, that's not an issue for us, because if you looked at the graphic of the kiln, the first zone is drying and devolatilization. And so we can have a wide variation of material going into there, going into the kiln. There'll be a drop in calorific value of the gas as the moisture comes out, but that gets evened out as you flow downstream. And by the time you get to the steam drum and the turbine, there's not much variation. So it's not really a problem.
And my last question would just be regarding the mass and energy balances. If you could provide different scenarios of moisture content, and dryer, no dryer, and show kind of, if you have a dryer. My understanding is a lot of times with the gasification process, the drying is such a high load on your, you oftentimes don't have any excess power at the end of the day to export. So maybe if you can provide some different examples showing higher moisture content with a dryer, lower moisture content without a dryer, just so we can kind of see how that.
I'll be happy to do that. But I would do that against a waste characterization of what we'll be looking at in Connecticut.
Yep. And Connecticut did do a waste characterization study, I think in 2016, and it's on DEEP's website. I'm pretty sure maybe James can.
Yeah, it was done in 2015, and it is on our website. It's possible we may do an updated one in the relatively near future, but at this time, the 2015 data is the latest. I will say, that waste characterization study indicated that 22% of the waste was food waste that was in the MSW stream, and about 40% total was organics. And because of those numbers, we've been putting a lot of increased focus on diverting food waste from the MSW stream, which, Barry, I know you mentioned was preferable for your processes.
Right. Well, you have to talk to Rob about that as well. If it comes in mixed, then there's going to be some cost in separation. If it's source separated, then we're good to go. Or mainly source separated.
Thank you, Jeff.
you.
And lastly is Don Stein from Amira. Don, thank you, and go right ahead. Don, you're on mute still. If
Yep,
you're,
I'm sorry about that. I
there you
forgot I
go.
was muted. No, what I started to say is my question is more, or is less technical than some of the questions have been asked. I think one of the things we as a committee have to start doing is whether it's a spreadsheet, whether it's a trade-off analysis, whatever, we got to figure out how we're going to compare these different technologies. There's great questions being asked. Obviously, the competitors are being competitive. But I think as we go from presentation to presentation, I think we need some kind of approach to being able to compare one presentation to another. What are the key issues? What are the key technologies? What are the environmental concerns, et cetera? So it isn't so much a question to today's presenters, but it's something we need to think about as a group going forward.
Don, you read my mind. So that was in my wrap-up comments, which I will do right now out of respect to everyone's time. But I was going to, first of all, thank our clerk, Gaia, for putting this all together, and ask her to go back over the recorded presentation and just get a feel for some of the questions that were asked, and put them in a chart, question asked and then answer from Connecticut Gasification, and then we will build on the questions asked, obviously, as we go on to different technologies, and then have, you know, a summary of the answers given, so that we have at least a one-pager to compare and contrast with. Don, thank you very much. And I just had one question for Barry before we wrap, and it's from the point of view of environmental justice, because if whatever we end up doing in the state, if anything, and if something is cited somewhere, there's going to be questions about environmental justice. In other words, if it is Hartford, how do you combat the argument? Well, we did it for the last 40 years. It's somebody else's turn to take this. But if any municipality that takes this, there's going to be concern about their residents' health and the like. And I'm interested in how you would answer. Well, you know, here we are. You're going to cite a garbage municipal solid waste processing facility, whatever it may be, in my backyard, and I'm going to have health concerns. So how would you, Barry, be able to help us answer that question?
Okay, so that question has come up. Limerick was mentioned earlier, and we were able to handle it there. And so, first of all, we anticipate that there'll be public hearings. We prepare for the public hearings, and the kind of issues are this: these things smell bad. Okay, well, what we do is we take outside air. The air that goes into the gasifier is drawn through the fuel prep building, and so any odors, any organic odors and so forth are combusted. So that's taken care of. These things do not smell. The next thing is there's going to be particulates. There's going to be smoke and so forth in the air. I think we've already covered that. We're going to have that's covered in the presentation. I'll let the presentation speak for itself. That was 1,000. The material in the presentation is from 1,000 tons a day. The next one is noise. There isn't any. And the last one is traffic. And the traffic we can't do much about, except we can make sure that we have turnout lanes before you go in, so there's no trucks queuing back onto the public roads, and that we have a maintenance facility on site, so if there's any problems with the trucks, they can be maintained. And there's a truck wash thing before they leave, if there's deliveries direct to the site. If we're running from a transfer station, then that's done with haul trucks, and that isn't such an issue.
And just to follow up, so one of the things with the EPR system is it doesn't look like a typical power plant. You could actually enclose, most of the building will be enclosed, look like a warehouse. And that would be where basically the waste to feedstock will be processed, and that's kept at negative pressure, as Barry indicated. And so there's no odors coming from that area. And that air would actually be used to feed into the gasifier as the feed air. The rotary kilns are actually horizontal, so that would be the only piece of equipment that's outside. So it wouldn't look, like I said, it wouldn't look like these big vertical, steel structures looking like a power plant. So it would be aesthetically more pleasing than anything that's in the area or anything that pretty much anybody else is going to build. And then as far as the emissions, for environmental justice, you're reducing the emissions in the area, and there's the emissions that is being produced by the low NOx gasification system that EPR has most likely will not be met by any other system.
Bob, what I will do when it comes to comparison and the comment about the spreadsheet, we've already done that, and I'll provide that information. It's factual information referenced. I'll provide that to Robert, and he can send that as well. So you can have the work that we've done on the comparison of the various available technologies out there.
That will be a starting point for Gaia, but I'm going to let the members of our committee make up their own, minds as far as collecting the data.
This
not questioning the facts, but the point was made that we have people that are competitors here, so
right.
I'm just trying to have the data be unfiltered at this point. So as I wrap up here, I'm going to say that, there was also some data that DEEP provided to us there was a Office of Legislative Research that came up with some data about municipal solid waste that Gaia will funnel down to us as well. It'll give you a good benchmark for what we're dealing with. She'll also send the verifications and the chart, also a copy of this presentation. I'm anticipating a meeting in October. I've reached out to Win Waste here in Bridgeport and invited them to present to the group here for October. That being said, I want to issue this publicly that if there are any other groups, Pyrolization, gas recovery, anyone else that has a potential technological option for how we go forward, please reach out to either myself or Gaia, and we will get you your time to present to the group so that we have accurate and meaningful cross-section of what we can potentially use as a solution to this problem. Ladies and gentlemen, thank you again for your time. We will be in contact for the next meeting, which, like I said, will probably be in mid to this time in October. And thank you for all the good questions. And this is a lot of material and a lot of data to absorb. So I know I'm going to be doing a lot of reading and rehashing over this to try to absorb it all. But again, thank you for this, and thank you for your willingness to help us on this committee going forward.
Thank you, Representative.
Have a good day, everyone.
Thank you.
Thank you.
Thank you.
Bye.
Thank you.
Bye.